So we're going back into area and volume, and we're just going to finish off the last few questions in this chapter, right? So the volume of a prism is 245 centimeters cubed. Find the value of K. Okay, so you need to know what you know about the volume. So the volume is the cross-sectional area times the length. So for a prism, the volume is equal to the cross-sectional area all multiplied by the length. Okay, in this case, it's important that we realize that the cross-sectional area of this prism is the area of the green surface there. So it's the area of the triangle. Now, the area of the triangle is the cross-sectional area, and the reason why is very, very important, because if I was to slice this prism straight down here, I'd end up with the same cross-sectional area. Okay, and that's very, very important. So the cross-sectional area is the rectangle. So I need to get the volume of the rectangle, and the volume of, the area of the rectangle. So the area of the triangle even. So the area of the triangle is half the base times its height. Times the perpendicular height. Okay, so it's half the base times the perpendicular height. So the area of that triangle is going to be equal to half the base, which is 7, times the perpendicular height, which is 5. So the area of that is going to be half the base times the height, which is 17.5. 17.5 centimeters squared. Just to be sure, where the units come from, the base is a measure of centimeters. The height is a measure of centimeters. So when I multiply centimeters by centimeters, I'll get centimeters squared. Okay, so that brings us back to the actual question that we're doing. So we know the area of the cross-sectional area. So we know the cross-sectional area. Okay, so the cross-sectional area is going to give us 17.5. So 17.5. That multiplied by the length, which in this case is K, gives us the volume. So let's fill in what we know. So we know the volume in this case is going to be 245, so we can fill that in, is equal to the cross-sectional area, which we just worked out, was 17.5, all multiplied by the length, which in this case is K. And I put that in pink because that's what we're trying to find the value of. Okay, so we formed an equation there. We now need to use our skills with algebra to solve the equation. So what we're trying to do is we're trying to get a value for K. So we want K equals, and we want to find out what K is equal to. So in order to move from one step to the next, we need to know what links one step to the next. So how can I go from this to this? So what you need to look at is you need to look at this and you need to think of what's happening here. So in this part of the question, in just here, when I have 17.5 in brackets next to K in brackets, what's actually happening is I'm multiplying those two terms. So at the minute, I'm multiplying K by 17.5. If I want to get K by itself, I need to do the inverse operation, which is the opposite operation, and the opposite times by 17.5 is to divide by 17.5. So if I divide the right-hand side by 17.5, I end up with K. But what I need to do then is I need to do the same to the left-hand side, and I need to divide 245 by 17.5. So 245 divided by 17.5 will give me an answer of K equals 1. Or not 1, sorry, 14. So if I divide both sides by 17.5, I'll get K is equal to 14. That's what the question asked. Find the value for K. That's what I found. The only thing I need to put in there is my units, and the units in this case would be centimeters. Okay, so that would be the first question done. So we've gone there to the next question. With this question, you can see it there. A farmer wants to sell his field. he wants more than 20, or he wants more than €24 per square meter. Mr. Dawn offers a total of 90,000 for the field. Should the farmer accept this offer? Give an explanation for your answer. Okay, so this question is asking us to do a lot, right? So it's asking us, first of all, we need to work out the area. And whatever the area is, we need to find out, is it worth €24 per square meter? Okay, so we'll start off by getting the area of that field. And how we get the area of that field is we break it up into two shapes. So we're looking at compound shapes here. So in order to break it up into two shapes, I'll just do that here at the side. So let me just tidy that up. That would be the first shape. And the second shape is obviously a long rectangle. Okay, so the first shape there, or we'll do the second shape first. So 39 is obviously 39. You can see that there. The length of this rectangle is 56. So just so you can fully visualize it, all I've done is I brought this right down here. Okay, so this will be one shape. Okay, 39 and 56. The other shape, we need to get dimensions for the other shape. So in order to find out the length of this, it's going to be the full length, which is 104, take away 56. So the length of this here, or the length of this here, will be the full length, which is 104, take away 56. So 104 take away 56 will leave us with 48. So this here will be 48. And the height of this here is going to be 39 plus 23. So 39 plus 23 will give us a total of 62. Okay, so we can start off with the first shape, and we'll say the area of the first shape will be half the base times perpendicular height. So the area of the first triangle is half the base times the perpendicular height. So let's put that in. Area of the triangle is equal to half the base multiplied by the perpendicular height. Okay, which will give us half of the base. In this case, I'm going to say that the base is equal to 48 and the perpendicular height is equal to 62. Okay, so, and with that triangle, it's important, just in case people can't visualize that, what I'm actually doing is I'm taking that triangle and flipping it this way, and I'm saying the base is 48 and the height is 62. Okay, I'll just show you that again. If I was to take that, I'm just literally flipping it like that, and you can see now that the base here would be 48 and the perpendicular height would be 62. Okay, so the base, like I said, was 48 and the perpendicular height was 62. Okay, so the area of that triangle is half the base, so 48, half 48 times 62 gives us a total of 1488 meters squared. So that tells us the area of the triangular part. I obviously need to find the rectangular part next, so I'm going to put that in next. So length by width, so it'll be 39 by 56. 56 by 39 even, I suppose you could say. 56 by 39. Which gives you 2180, or 2184 even. So I found the area of the triangular part. I found the area of the rectangular part. Now I need to find the total area. So the total area will be, add the two of them together. So total area and that will be equal to 1488 plus 2184, and that gives us a total of 3672 meters squared. So now I've worked out what the total area is. Okay, now if he's offered 90,000 for the field, we want to find out how much that is per square meter. Okay, so he's got this amount of square meters. He's been offered 90,000, and I want to know what he's getting for 1 square meter. So let me do that. I'll do it in green because it's almost like it's ratios. So he's been offered 90,000 for all of this. So for 3,672, he's been offered 90,000 euro. He wants to know how much he gets per square meter. So this is meters squared, obviously. This is euros. He wants to know what he gets per square meter. So he wants to know what he gets for 1 square meter. So to find out what he gets for 1 square meter, I need to divide both sides by 3,672. So if I divide 90,000 by 3,672, I'll get an answer of 20. Let me just fix that. 24.50980392. Okay. So for every square meter, he's been offered 24.5 euro, you could say. So should the farmer accept this offer, in this case, it looks like he'll get more than 24 euro per meter. So the answer to this will be yes. And you can say, as he is being offered 24.5 euro per square meter. Okay, so that's that question sorted, and we're ready to move on to the next one. Okay, so the next question there, again, it's area and volume. The large circle has an area of 129. Okay. What is the area of the shaded region? So we need to find out the area of the shaded region. Give your answer correct to 1 decimal place. So the formula for the area of a circle is pi r squared, and we'll need that. Okay, so you get that from your log tables typically. But you need to use that to find the radius of the large circle, okay, given the information you have. If you found the area of the large circle, then you'd be able to get the area of the small circle, okay, and if we times that by 2 and took it away from the large one, you'd know your answer. So we'll just leave it there for 1 sec. Okay, so what I'm going to do is I'm going to fill in the information I have. I'm going to start off by looking at the large circle, and I know that the large circle has an area of 129. So 129 is equal to pi r squared. I'm trying to find the radius. Pi represents a number. This is obviously a number, so the only unknown here is the radius. So if I want to find the radius, I need to isolate the radius. And what that means is I need to put r squared by itself equals, so in order to find out what r squared is equal to, I need to get rid of this pi. So currently the operation between these two is times. So if I want r by itself, I need to divide this side by pi. If I divide the right hand side by pi, I'll be left with r squared. But because I divided the right hand side by pi, I need to divide the left hand side by pi. So r squared is equal to 129 divided by pi. So if I want to find out what r is equal to, I need to get the inverse operation, and the opposite squared is square root. So I would need to get the square root of both sides, so 129 all over pi. So r in this case will be equal to, and if I type that into a calculator, the square root of 129 all over pi, I get an answer of 6.40796 1869. Okay, so that's the radius of the large circle. So let's just put that in, because it's important that we fill in the information that we have. So the radius of the large circle correct to one decimal place is 6.4. So if the radius of the large circle is 6.4, then I need to be able to find the radius of the small circle, and the radius of the small circle is going to be half the radius of the large circle. So, and half that would be 3.2. Okay, so next thing I need to do, and I'll do it here, is I need to get the area of the small circle. So I'll start off now by getting the area of the small circle. And in order to get the area of the circle, I need to get pi r squared. So we're getting the area of a circle, and we're looking at the small circle. I just put the small circle there in brackets so that we know. So the area of the small circle has a radius of 3.2. So is equal to pi times 3.2 all to be squared. So pi multiplied by 3.2 squared will give us 32.16990,877. Okay, so that's the area of the small circle. I've got two of them. So the area of two small circles is obviously going to be twice that. Okay, so it's going to be twice that, and if I got twice that figure, I would end up with 64.33981,755. So that tells me the area of the two circles. So if I know the area of the large circle, okay, which was given to me in the question, 129, and if I know the area of two small circles, in order to find the area of the shaded region, I'll do that next. So the area of the shaded region it'll be equal to 129, which is given in the question. So the area I can see there is 129 of the large circle. The large circle has an area of 129. And I need to take away the area of the two small circles, and the area of the two small circles, okay, you can see there we worked it out to be 64.3398. So I'm going to subtract that. So subtract 64.33981755, and that will give me my answer. So 129, subtract the answer, which is 64.66018245. It asked me to give my answer correct to one decimal place. So if I go to correct to one decimal place, all I need to do is go back one, draw a line down there, and see the number that follows. So my answer will be 64.7. And are we dealing with meters or centimeters? Centimeters. Okay.